Welcome! Today we're going to demystify a term you hear all the time, machine learning. We're going to break down how computers actually learn, and I promise it's way more intuitive than you might think. So let's jump right in.
So let's just start with this one big question. For, most of computing history, we've had to tell machines exactly what to do, every single step. But what if they could just figure things out on their own? What if a computer could learn from experience, kind of like we do? That single idea, that's the absolute heart of machine learning. All right, first things first. Let's tackle the biggest point of confusion right out of the gate. What's the difference between artificial intelligence and machine learning? You hear these terms thrown around all the time, sometimes like that they're the same thing. They're not.
The relationship is actually pretty simple when you see it like this. Think of artificial intelligence, or AI, as the whole big universe of making machines smart. Machine learning is a specific, really powerful way to do that. It's a crucial piece, a subset of that bigger AI world. And this slide just lays it out perfectly. On the left, you've got old-school, rules-based AI. A thermostat is a great example. If the temperature drops below 70, then turn on the heat. Simple. The rules are hard-coded. But on the right, you have machine learning. Your spam filter isn't given millions of rules. No way. Instead, it's shown thousands and thousands of emails, and it learns for itself what spam looks like. It's really the difference between following a recipe and actually learning how to cook. So if a spam filter can learn to cook, how does that learning really happen? Let's dive into the core idea of what it means to learn from experience. And this isn't some brand new idea. Way back in 1959, an AI pioneer named Arthur Samuel just nailed the ambition perfectly. The goal wasn't just to make a computer play checkers. It was to make it learn to play better than the person who programmed it. I mean, think about that. The student actually surpassing the teacher? That's a powerful idea. And here's the absolute key. Learning isn't just about memorization. A model that only memorizes the old data it's seen is totally useless. The real goal is this word right here, generalization. It's the ability to see what it's learned and apply that successfully to brand new stuff it has never seen before. That right there is the true test of learning. And we can kind of boil this whole process down into 3 basic steps. First, you train the model. You just feed it a ton of data. Second, the model does its thing. It works to generalize patterns from all that data. And finally, it uses those patterns to make inferences, predictions on totally new data. Train, generalize, infer. Now it gets even more interesting because it turns out there isn't just one way to teach a machine. There are 3 main styles of training, and each one is good for different kinds of problems. First up, we've got supervised learning. The best way to think about this is like studying with flashcards or having an answer key. You give the machine data that's already labeled with the right answers, like here are a million pictures and this one is a cat, this one is a dog. The model's job is just to figure out the patterns. It's super powerful, but the catch is someone has to create all that labeled data first, which can be a ton of work. Next is unsupervised learning. Now we take away the answer key. You just give the model a whole bunch of data and basically say, find something interesting in here. It has to find the hidden patterns or groups all on its own. Think about getting a giant mixed pile of laundry and having to sort it into whites, darks, and colors without anyone telling you those categories even exist. It's all about discovery. And finally, there's reinforcement learning. This is all about learning from trial and error. You have a program, we call it an agent, and it takes actions in some environment, like a robot trying to walk or an AI playing a video game. It gets points, a reward for good moves, and penalties for bad ones. And over millions of tries, it figures out the strategy that gets the most points. It's exactly like training a dog with treats. So to quickly recap, it's really about picking the right tool for the job. Got labeled data and you need to predict something? That's supervised. Need to find hidden patterns in a mess of raw data? Unsupervised is your friend. And if you're trying to achieve a goal through trial and error, you go with reinforcement. Okay, so within machine learning, there's this one area that has just completely supercharged everything in the last decade. So let's talk about the power-up, deep learning. So what is it? Well, deep learning is a type of machine learning that's kind of inspired by the structure of our own brains. It uses these things called neural networks that have lots and lots of layers. That's the deep part, to learn incredibly complex and subtle patterns from just enormous amounts of data. This slide is such a great way to picture the difference in power.
On the left, traditional ML is trying to find one single smooth curve that fits the data. But look at the right. Deep learning is more like having an infinite box of tiny, flexible little lines that it can piece together. This lets it form these much more complex, precise shapes and capture patterns that the other models would totally miss. That flexibility is its superpower.
But all that power has a price. Deep learning models are hungry. They need a ridiculous amount of data, what we call big data, to learn from. And you need really powerful, specialized computer chips, like GPUs, to do all the heavy lifting. It's that combo, massive data and massive computing power, that unlocks their amazing performance. Okay, so we've covered the what and the how. For this last part, let's talk about the where. Because the truth is, you are interacting with machine learning all day long. I mean, just think about it. When Netflix suggests a movie for you, that's machine learning. When your phone unlocks with your face, that's machine learning. When you talk to a chatbot, translate a web page, get a fraud alert from your bank, and yep, that spam filter we started with, it's all powered by machine learning. It is everywhere. So if you remember just one thing from all of this, let it be this. Machine learning is a fundamental shift. We've gone from spending all our time writing specific rules for the computer to building computers that can learn and create their own rules just by looking at data. And that leaves us with this final, really fascinating question. We've seen what this tech can do today, from recommending movies to spotting diseases. But as these machines get even better and better at learning, what are the really big, important problems we should point them at next? Definitely something to think about. Thanks so much for watching.